So the next item is hormonal control. The hormonal control is also used in order to influence the blood pressure. So either it can increase or decrease the blood pressure according to the body needs. The first one that we have is angiotensin 2. Angiotensin 2 is going to produce vasoconstriction, and because of the vasoconstriction, then obviously the blood pressure will increase. We will cover angiotensin 2 later on when we cover the kidneys chapter. Aldosterone is also related to angiotensin 2. Therefore, we will cover also together with angiotensin 2 when we cover the kidneys. But the main job of the aldosterone is to reabsorb sodium. And because aldosterone reabsorbs sodium, water will follow due to osmosis. And since water follows, it will increase the blood pressure because obviously water will increase the amount of fluid in the blood. The next item would be natriuretic peptides. The most important one out of this is the atrial natriuretic peptide. Obviously, atrial sounds like atrium because this is produced by your heart, more specifically the atrium. So when there is too much pressure, this increased pressure will hit the heart with force, in particular the atrium, the right atrium, because that's where the blood returns. So in order to avoid that, the atrial natriuretic peptide will reduce the blood pressure, okay, by stimulating the release of sodium and excretion or removal of sodium through the kidneys. And since you remove sodium, then obviously water will be removed as well. It basically has the opposite effect as aldosterone. The next one is antidiuretic hormone. This one right here, antidiuretic hormone. Diuresis means to urinate. Therefore, antidiuretic means anti-urination. So that means that if you don't urinate, you will retain water. And if you retain water, then obviously the blood pressure will increase. The next one is epinephrine and norepinephrine. Obviously, these two hormones, they are going to stimulate vasoconstriction, and because of vasoconstriction, the blood pressure will increase as well. Okay. So after that, we have purposes of vasal reflexes. So vasal means blood vessels, right? So reflexes in the blood vessels, we have two main kinds. Either the blood vessels dilate or the blood vessels that are going to constrict. If they dilate, obviously they produce vasodilation, therefore the blood pressure will decrease. And if they constrict, they obviously will produce vasoconstriction and the blood pressure will increase. I think this is just repetition of what has been mentioned before. Obviously, right here it says, for example, okay, according to your body needs, obviously this vasoconstriction and this vasodilation will happen, right? If you are eating, then obviously a lot of blood will go into your digestive system in order to help you digest the food. If you are playing, I don't know, in this case, soccer or any other physical activity, then obviously the blood flow will move from your digestive system into the muscles to provide them with enough blood in order to perform the action that they need to perform. Obviously, this causes a problem because a lot of times when we eat, we are at the beach, right? And then once we finish eating, we just run into the water and we try to swim. And a lot of times this causes muscle cramps and things like that, and people drown because of that, right? There's a lot of cases in which people are drowning because obviously they have muscle cramps. And that's a lot of times the reason for that is this distribution of blood in your body. Okay, so let's keep scrolling down. This is just differences in blood flow. You don't need to know that. And then that's about it. The next topic is capillary exchange. I think I explained this a lot already. I said that the main job of the capillaries is to allow the exchange of nutrients and waste that needs to be removed from the cells and the nutrients that need to go from the blood into your cells. And this happens mainly at the level of the capillaries. Right? This is a very important concept to understand. So if we scroll down, we can see that the way this happens, again, this is a capillary. As I said, this is just one layer of cells, one after another, forming the walls of your capillary. And as I mentioned before, they are so tiny and so thin that there's only one red blood cell that can go through it. Main processes by which the substances can come out your red blood cells into the cells that you have in your tissues, then or vice versa, from your tissues into your blood, there are going to be the filtration pores, transcytosis, in which the endothelium, the cells that you have in your capillaries, will absorb or will capture some molecules, and then they will be released on the other side. Obviously, diffusion is a very important process, right? As well as the allowing of substances to pass through intercellular clefts. So those are the main concepts. Again, diffusion, osmosis, passive transportation. Examples of passive transportation are very important. So we mentioned that obviously these things are going to be able to pass or cross from one side to the other through the endothelial cell cytoplasm, in the cytoplasm, intercellular clefts, filtration pores. Diffusion, obviously, we already mentioned this several times, especially in Anatomy 1. Diffusion is the movement of molecules from high concentration to low concentration. And obviously, this includes waste and gases such as oxygen and carbon dioxide. Transcytosis already explained, right, in which endothelial cells will pick up material on one side and they will transport that to the other side of the endothelium in order to be released. Filtration or reabsorption, obviously we already mentioned that before as well. Those happen, I mean, in particular, filtration happens because there is difference in pressure. Obviously, osmosis is the movement of water from high pressure to low pressure. Very important concept to understand, again, because this happens at the level of the capillaries. So right here you have the capillaries, in this case in the area where you have the arteriole, right? That's where you have a lot of gases, for example. So you must provide the gas from the red blood cells into the cells that you have in your tissues. And that's possible because you're going to have more forces coming out than the forces coming in. Therefore, this will force, for example, the gases to come out into your tissues, and your tissues will receive the oxygen, which is necessary in order for the cell to perform the jobs every day. At the level of the venule, right, towards the end, in the capillary again, right, you're going to have that you have more forces going in, 20, than the ones that are going out. Therefore, this allows things from your tissue, things from your tissues, like for example waste, to go from your tissues into the blood that you have in these capillaries that eventually will reach the venules in order to get rid of them at the level of your lungs. So this is very important because, again, the gas exchange and the nutrient exchange and all the things that need to be exchanged between your tissues and your blood happens at this level due to the fact that we have these different forces. One thing that I want to mention is that the force that makes these things go from your blood into your tissues is basically filtration pressure. And the ones that will allow you to push the things from your tissues into your blood is basically osmotic pressure. Okay, so let's keep going. This is very important. If we keep scrolling down, we go right here where you see the colloid osmotic pressure. As I said, is the one that pushes the things basically from your cells into the blood. And right here you have the net filtration pressure, which is the one that pushes the things from your blood into your tissues. Again, in here, showing you the forces, right? The total amounts of forces that will help you with this exchange that happens at the level of the capillaries. You don't need to know these values. It's just information that you need to read, but that's about it. So if we keep scrolling down, we said variations in capillary filtration and reabsorption. Obviously, there's always going to be variations because we are always having different physical activities and different metabolic needs, and because of that, the filtration and reabsorption at the level of the capillaries must be adjusted. Okay, so if we keep scrolling down, edema is not something normal, right? That's the accumulation of excess fluid in a tissue, but you don't need to know that because obviously that's not normal. Obviously, when you have edema, certain areas of your body are going to increase in size due to the fact that there is accumulation of fluid. That's next topic, venous return and circulatory shock. Obviously, circulatory shock is not normal, so then that's not anatomy or physiology. So we're not going to talk much about it, but we need to talk about venous return, which is the amount of blood that returns into your heart, right? Okay, So obviously in here you have some history, how this was tested before. That's just history. Mechanisms of venous return. What causes your blood to return to your heart? Well, the very first one is obviously the pressure gradient produced by your heart, right? Your heart pumps with certain force, and that's enough in order for the blood to come back into your heart. Gravity. Gravity obviously helps you to push the blood from your brain and your neck into your heart, right? So there's not much that you need to do in there because gravity will do that job for you. At the level of the legs and your feet, for example, now you don't have the gravity to help you pushing the blood into your heart. So then you will use the skeletal muscle pump. Skeletal muscle pump is the muscles that you have at the level of your legs that every single time they contract because you are walking, they will produce pressure in your veins, and your veins, together with the valves that you have in there, will help the blood to return back into your heart. The next one that we have is the thoracic pump or respiratory pump. Every single time you breathe, right, the pressure in your thoracic cavity will decrease and the pressure in your abdomen will increase. Because this happens and there's an increase in pressure in your abdomen, this will help you push the blood towards your heart. Cardiac suction. During the ventricular systole, the valves will be sucked into the ventricle. Therefore, this will increase the area in your atrium, therefore producing a force that it appears to suck the blood towards your heart. Okay, that's why it says in here the AV valve collapses downward and creates a slight suction that draws blood into your atriums. Okay, so those are the factors that are going to help you return the blood into your heart. Obviously, again, like in any other case of physical activity, the venous return physical activity, if you produce any kind of physical activity, the blood will return faster because obviously the heart will pump faster and all the activities in your body will increase. Okay, there's a term in here called venous pooling. That happens when you accumulate blood in your legs. For example, when you are sitting down for a long period of time, or when you are laying down in your bed and you don't move your legs, then that's when that happens. That's why when you have surgery and things like that, they put this kind of like pressure cuffs at the level of your legs. So these cuffs will produce pressure from time to time to allow you to move the blood back into your whole circulatory system so you don't accumulate the blood at the level of your legs. So if we keep scrolling down, we have circulatory shock. As I said, I'm not going to talk about it, even though, well, there are two in here, cardiogenic and low venous return. Cardiogenic got to do with the cardiac output, right? Obviously, if you don't pump enough blood because your cardiac output is less than what it's supposed to be for whatever reason, then obviously that's going to cause circulatory shock. Okay, that got to do with the cardiac output, right? There's not enough blood in your body because the cardiac output is not enough. Or low venous return, because if you don't return enough blood to your heart, then obviously your heart will not be able to pump the right amount, so the cardiac output is going to be affected, and that's going to cause circulatory shock, right? And this low venous return obviously can be because of the venous pooling that we were talking about before. The blood gets stuck at the level of your veins. Next topic is special circulatory routes. There's not much special about it. The brain, it must have blood all the time, because the moment that you don't have blood in your brain, right, you're going to pass out. So it's not that it's 1 minute or 2 minutes, it's just seconds you pass out. So you have to understand the blood flow in your brain is very important for that reason. Okay, and if it goes more than that, like maybe 4 or 5 minutes, then obviously there's going to be damage to your brain and you will never going to be the same, right? Okay, so then skeletal muscles, same thing. Obviously the muscles are going to get a lot of blood when you have physical activity. The lungs are the only areas in which the artery contains a whole bunch of carbon dioxide. That's the main thing. And the veins contain a lot of oxygen, which is completely opposite to what happens in your circulatory system. Next topic, anatomy of the pulmonary circuit. I think I already spoke about it a lot when we were covering the heart, right? We were saying that we have a pulmonary trunk, 2 pulmonary arteries, and then you have 4 pulmonary veins, two from the right side, two from the left side. That's about it.